Okay, Wildcats, here we are on our second day of Lesson 2. This time it is Earth's layers. So, you need to take your piece of paper, flip it over to the back. Now you can see I already did my notes. I took a video earlier, and as I was transferring it from my phone to the computer, it disappeared. So I have to re-record this video. Okay, red pen, Earth's layers, capital E-A-R-T-H''S. Capital L-A-Y-E-R-S, Earth's layers. Switch to our pencil. Earth has a layered structure. Most of these layers are made up of solid rock. The innermost layers are mostly a mixture of metals. So we wrote over here, most solid rock, M-O-S-T, solid, S-O-L-I-D, rock, R-O-C-K. Innermost, I-N-N-E-R, M-O-S-T equals mix of metals, M-E-T-A-L-S. Earth's layers vary in thickness. The crust, the uppermost layer, is much thinner than the other layers. The crust is nearly all solid rock. Under the continents, the crust is mostly granite and other low-density rocks. Below the oceans, the crust is mostly made of basalt, a dark, dense rock. So they're telling us the layers have different thicknesses. The crust is this tiny little layer that all the living things live on. It's very thin, kind of like the skin of a peach. And then underneath the continents, or the land, is granite, and it's low density, so it kind of almost floats. But under the oceans, it's mostly basalt, which is very dense and heavy and sinks. Okay, so over here, thickness, T-H-I-C-K, N-E-S-S, varies, V-A-R-I-E-S. That means it's thicker and thinner in different places. Crust, much thinner, T-H-I-N-N-E-R, less than sign, other, O-T-H-E-R. So the crust is much thinner than the other layers of the Earth. Granite, G-R-A-N-I-T-E, under, U-N-D-E-R, continents, C-O-N-T-I-N-E-N-T-S, granite under continents. Basalt, B-A-S-A-L-T, under. Oceans, O-C-E-A-N-S. So what we're saying is that there is granite under the continents, but basalt under the oceans. Okay, what's next? The crust is by far the thinnest of Earth's layers. Under the continents, the average thickness of the crust is about 40 kilometers, which is 24 miles. But it may be as much as 70 kilometers, 42 miles, in mountainous regions. So let's think about those distances. 24 miles is about the distance from Wasco to Bakersfield. 42 miles is about from Wasco to Arvin on the complete other side of the county. So that's a pretty good distance. That's about how thick the crust is. The crust is even thinner under the oceans. The ocean floor crust has a thickness of about 7 kilometers, or 4 miles. That's probably about the distance from, like, not even Wasco to Shafter, like Wasco to where that big giant sign is that talks about the Rose Festival. The solid layer just below Earth's crust is the mantle. The mantle is denser than the crust and contains more iron and less silica. The mantle is about 2,900 kilometers, or 1,800 miles thick. It makes up more than 2/3 of Earth's mass. This rigid upper mantle and crust combine to form a rigid shell called the lithosphere. Lithosphere. Remember, sphere is like a ball or something round and spherical. So that's what they're telling us. Okay, so what are all these things? Let's compare the distance of the crust. The crust's thickness is about as thick as it is from like Wasco to Bakersfield or Wasco to Arvin. But this 1,800 miles of the mantle, that's like from Wasco all the way to the middle of the country, like in Michigan or Missouri or Texas, all the way to Texas and Mississippi. So the mantle, this kind of meaty part of the peach, or this orange meaty part of the planet, is much, much, much thicker than the crust. And that's why it makes up about 2/3 of the Earth's mass. Most of the Earth is made up of mantle. Okay, so what notes did we take? Squiggle 4 miles, mi, under, UNDER, ocean, OCEAN. Squiggle 24-40 miles, mi, continents, CONTINENTS. So what we're saying is that the Earth's layers, or the crust, is about 4 miles thick under the ocean, and anywhere from about 24 to 40 miles thick under the continents. And that's because you have so much land mass and you also have tall mountains. Okay, mantle, MANTLE, squiggle, 1,800 miles, MI, thick, THICK. Greater than 2/3, 2/3, Earth's, capital EARTH'S, mass, MASS. So not only were they talking about how thick the crust is under the ocean, which is actually very, very, very thin, a little bit thicker at the continents, and then the mantle is way thicker than any of those, and that's why it makes up more than 2/3 of the Earth's mass. Most of the Earth is mantle. Okay, let's come back over here. Below the lithosphere, the rock material in the upper mantle is much softer. This material can flow very slowly, like plastic that has been heated almost to its melting point. The solid lithosphere can be thought of as floating on this upper mantle. The plastic part of the mantle beneath the lithosphere is called the asthenosphere. Asthenosphere. So what they're really trying to tell us is the soft part of the mantle is kind of soft and squishy and flowy. I would think of it like extremely hot Play-Doh, and it would have the consistency of Play-Doh where it can squish and move very slowly. Okay, let's see if we put that here. Upper, UPPER, mantle, MANTLE, is greater than sign, softer, SOFTER. So the upper mantle is a lot softer than the crust or any of the other layers. Lithosphere, LITHOSPHERE, lithosphere. Squiggle, quotes, floating, FLOATING, close quotes. So the lithosphere is kind of floating on the mantle. The upper mantle and the crust is the lithosphere, and it's kind of floating on top of the lower mantle. And that makes sense when we go back and think about the granite was called lower density, so it kind of floats on top, and that's why we get these continents out on the surface. But that heavier, denser basalt sinks to the bottom of the oceans and stays down there, so that's why the water is able to be on top of it. Okay, the innermost of Earth's layers is the core, which extends to the center of Earth. The core is divided into two regions or layers, the outer core and the inner core. The outer core is about 2,200 kilometers, or 1,400 miles thick, and is the only layer that is in a liquid state. Whoa, okay, so it's in a liquid state. It's basically liquid metal. It is made up of molten iron, with some nickel, sulfur, and oxygen also present. So iron, that is most of the metal that you see. If something is made out of steel, then that's mostly iron. Cars have a lot of iron. Basically, anything metal and anything magnetic is iron. Nickel is a very shiny metal. A lot of times you'll see nickel on like things that are chrome plated. And then sulfur is that thing that smells like rotten eggs. Like they put sulfur gas in natural gas to make it stink so you can smell it and know if there's a leak. The solid inner core, about 1,200 kilometers or 720 miles thick, is even hotter than the outer core. Wait a second, how can it be hotter, but that's the only one in a liquid state? I thought if things were really hot, they were liquids. Okay, let's see what they say. Made up of nearly pure iron, the inner core is about the size of the moon. Whoa, so like the moon fits inside the Earth. Or it would. Its temperature is about 5,000 degrees Celsius, about as hot as the surface of the sun. So yes, the inside of our planet, the inner core, is solid iron, and it's so hot, it's as hot as the surface of the sun. So how does that not explode and burn us up? The extremely high pressure from above keeps the iron from melting. Oh, okay. So the outer core and all this thick mantle and the crust is all so big and thick and heavy that it just mushes and smashes all that high iron together and forces it to be in a solid state. It's pushing on it so hard that even though it's as hot as the sun, it still stays a solid. That's amazing. A hard-boiled egg is often used to model Earth's structure. Others compare Earth to a peach or similar fruit with a thin skin and a pit in the center. Okay, so let's look over here. Core equals 2 layers, C-O-R-E for core, layers, L-A-Y-E-R-S. And then what I did was kind of like a little T-chart right here for the inner and the outer core to separate those two pieces of information. Okay, the inner core is about 720 miles thick. The outer core is about 1,400 miles thick. That's 1,400. Those are commas. So the outer core is actually about twice as thick as the inner. Interesting. Okay, the inner is solid and hotter. Greater than sign, 5,000 degrees Celsius, sun. Solid, S-O-L-I-D, and is down, make a number 3, and down again. Hotter, H-O-T-T-E-R, greater than sign, 5,000, 5, 000. The little circle up here at the top for degrees, capital C for Celsius. Then we put sun. Outer liquid metals, L-I-Q-U-I-D, metals, M-E-T-A-L-S. Inner, squiggle, pure, P-U-R-E, iron, I-R-O-N, equals moon, M-O-O-N. Similar, S-I-M-I-L-A-R, to T-O, peach, P-E-A-C-H. So the inner core is about half as thick as the outer, or the outer is twice as thick as the inner. The inner is solid and hotter than the outer. It's so hot, 5,000 degrees Celsius, that's as hot as the sun. The outer core is made of liquid metals, but the inner core is basically made of pure iron, and it's about the same size as the moon. So let's put the word size here, S-I-Z-E. And it's similar to a peach. Well, they literally ask us, how is Earth like a peach? Okay, the pit of the peach is kind of like the core. There's a solid core in the middle. All that fleshy stuff of the peach that you chew on and eat, that's like the mantle. Most of the peach is made of the flesh. Most of the Earth is made of the mantle. And then the peach has this thin, kind of soft, fuzzy skin around the outside. And you can actually peel it off, sort of. The Earth has a thin layer around the outside called the crust. So that's how they're similar. Now it says, how is it different? Well, obviously a peach doesn't have liquid hot metal swirling around in the outer core. And its inner core, even though it's solid, isn't 5,000 degrees Celsius like ours is. Okay, now last thing, let's draw a picture of the Earth's layers. So the way to start this is make a little dot in the center and then put a very tiny circle around it. The dot is the inner core, I-N-N-E-R, core, C-O-R-E. It is super hot, S-U-P-E-R, hot, H-O-T, and it is solid, S-O-L-I-D. The outer core, that's going to be represented by this outside circle, O-U-T-E-R, core, C-O-R-E. Liquid metal, L-I-Q-U-I-D, metal, M-E-T-A-L. So now we're going to be able to visualize and see what all these layers are and how they're special or unique. Okay, then I drew a slightly bigger circle around those words. Notice how it's just barely around those words. I labeled that mantle, M-A-N-T-L-E. Now the bottom or lower mantle is asthenosphere, A-S-T-H-E-N-O-S-P-H-E-R-E. I put quotes, plastic, P-L-A-S-T-I-C. That's the part where it's kind of squishy and plasticky, maybe has the consistency of like Play-Doh. Okay, then I drew the biggest one yet, all the way around the outside, and I labeled that the crust, C-R-U-S-T, and I wrote right on top of the line so I know that that thin line is the crust. It's thin, T-H-I-N, and rocky, R-O-C-K-Y. That's where all the life is. Capital L, capital I, capital F, capital E, exclamation point, life. All the life that we know of on Earth lives in the crust, just that thin little layer on the outside. Okay, then I made a little bracket where I go squiggle, point, and then come back with a squiggle, and that's a bracket. And I put lithosphere, L-I-T-H-O-S-P-H-E-R-E. So what I'm trying to tell myself is the crust and this upper part of the mantle make up the lithosphere. That's the special name for it. All right, remember you can watch the video more than once. You can pause it along the way. Good job. Thank you for persevering, and roar Wildcats.